8.4 graphing rational function. Let's go through this worksheet. So we want to find the vertical and horizontal asymptotes for each. So remember, the way you find the vertical asymptote, standard hasn't changed. Set the denominator equal to 0. You're good. Horizontal asymptote, especially in this class, what we're going to do is look at the powers. Top bigger than bottom, none. Truth be told, it's actually a little more complicated than that. It's all about how far it is, but for this class, top bigger than bottom is none. In advanced math classes later on, you'll learn the differences in how they relate. But for this class, if the top power is bigger than the bottom power, it's none. If the bottom power is bigger than the top power, it is 0. And if they're the same, we take the ratio. Okay, so here, horizontal asymptote, that's what the first thing to look at. Top power is bigger than the bottom power, so none. No horizontal asymptote. Vertical asymptote, very simple, so the bottom equal to 0. Solve it. 6x equals negative 12 divided by 6. X equals negative 2. Negative 2. So that's one vertical asymptote. Next one, horizontal asymptote, look at the powers. They're the same power. So in this case, we do the ratio. So what does that mean? You take the ratio of the coefficients. So 1 over 1 in this case, these guys. So y equals 1 over 1 or just 1. Vertical asymptote, so at the bottom equal to 0. So we set x plus 1 equal to 0. So x equals negative 1. Okay, let's move on. Next one, horizontal asymptote, the bottom power is bigger, so 0. Vertical asymptote, so at the bottom equal to 0. Some people freak out with the square, you just square root it, and then you just get x plus 4 equals 0, so x equals negative 4. There we go. Next one, this one I'm asking about holes. Remember, the way you find holes is you factor, and if stuff cancels out much like 8.1, in section 8.1, and then you have a hole. So to factor the top, two things that multiply to get negative 12 back to get 4. Looks like x plus 6, x minus 2. The minus 2's cancel out, that's our hole. So our hole will be at x equals 2. Now, remember, we're not done with the problem. There's still leftover. The problem is x plus 6 now. So this equation here is just x plus 6. So what does that mean? Horizontal asymptote. Well, there's no power on the bottom, so the top power is bigger. So none. Vertical asymptote. Well, there's no denominator, so none again. Now, if I want to find the point of the hole, like the actual what value is the hole, like right now I know it's at x equals 2, but what's the y value? Because the hole is generally a point. Well, all you gotta do is plug into what's left over. So plug 2 into x plus 6. So you get 2 plus 6, and you get 8. So 2 and 8. So that's where the hole is at, right? So you just get your x value, you plug it back into the function, which the only thing left over is this guy. So you just get 8. So the hole to be at 2, 8. So let's do some graphing. So this one, first horizontal asymptote, I see they're the same power, so 1 over 1. Right, so you take the coefficients, which is 1 over 1. Vertical asymptote, so the denominator equal to 0. So you get x plus 2 equal to 0. So you get x equals negative 2. Hole, now nothing canceled out, so there's no hole. So now let's graph this, right? So I always like to put asymptotes first, so y equals 1. X equals negative 2. Now the way we graph it, it's not like last time. It's not just, oh, positive on top. This is a variable on top, so it's not sure. So there's a couple ways to do this. One is to make a table and plug in points on this side and this side and see where the graph goes. The other one, let's use a calculator. We have technology, let's use it. So we want to graph it. So we're going to go y equals. I'm going to type this in. The easiest way to type this in is press alpha y equals and then fraction. That's if your calculator is updated. If not, use parentheses. I'll do that for the next one. X plus 2. Like this. Enter. Now you can graph it. My window should be zoom standard for this graph, so like zoom 6 if you're not sure. So it's like that. So that tells me, oh, so it's on this side and it's on this side. Now that should not ever go past asymptotes. That bottom looks like it's getting really close to it. Anyway, that'll be my graph. My domain and range. Remember, domain is my x value. So what's the one thing it can't be? Negative 2. X equal negative 2. And my range, what's the one thing it can't be? My y value 1. and -2 looks ugly. There we go. So there you go, that's the graph. Next one, horizontal asymptote, the bottom is bigger than the top, so 0. Vertical asymptote, so the bottom equal to 0. So x minus 2 squared equals 0. Again, square root both sides, you get x minus 2 equals 0. Then you need to add 2, so 2. There's no holes again, nothing canceled out, so we have this. So let's graph it. Y equals 0 is my horizontal asymptote, and x equals 2 is my vertical asymptote. And again, a couple ways to do it. You can either make a table and plug values in, which is not too bad, or you could use your technology. Since we have a calculator, let's use it. Or you can also just do it on decimals if you don't have a calculator. Just type it in the way you see it. So x minus 2 squared. Hit graph. And I get, so this part of the graph gets value and this part of the graph gets value. Like that. My domain, right? Remember domain's the, oh, that's an ugly graph. I'm gonna fix that. I can't live with that graph right now. Okay, so like this, gets really close, curves that way. Much better. Not perfect, but much better. Actually, that annoys me too. You should be getting closer as you get closer to the line. That was kind of shooting outward. That's much better. And we have a graph like that. My domain. So what's the one thing can't be? It looks like the only thing can't be is x not equal to 2. Now my range, right? You go, oh, y equals 0. But look at the graph. There's nothing below 0. It's 0 to infinity. Or if you want to say y is greater than 0. That's why it's also important to double check your graph to make sure you don't mess with your domain range. Okay, next one. More graphing, I assume. So let's find some asymptotes. So horizontal asymptote, look at the powers. They're both the same. They're both 1. So we look at the ratio of the coefficients. So 1 over 1. So just 1 again. Vertical asymptotes at the bottom equals 0. I'm gonna get -1. Nothing cancels. So no holes. Plot the graph. Always use asymptotes first. Like that. Again, then I could either make a table and plug values in. I'm gonna do that this time since I'm here. So let's look what that looks like. So I'll put a couple points on this side. So I'll plug in like 0 and like 3 just to see what happens on the x side. If I plug in 0, I get -3 over 1. So -3. If I plug in 3, I get 0 over 4. So I get 0. So -3, 0, -3, and 3, 0. My graph looks down here. If I plug in points on this side, so I'm just picking stuff, let's see, -2, and let's say -5, just to get a feeling what it looks like. So if I do -2, plug in -2, I get -2 minus 3 is -5, over -2 plus 1 is -1, so I just get 5 actually. And if I plug in -5 minus 3 is -8. -5 plus 1 is -4. So I get -2. I get 2, +2. I was scared for a second. I'm like, that shouldn't get that. So you get something that looks like this. Right, so again, you can do it by making a table, making values, or you put in your calculator. Next one. So horizontal asymptote, bottom is bigger than top. This is x, so it's like x squared on the bottom. And we have like nothing on top. X is 0. So bottom wins. So y equals 0. Horizontal, so we actually have 2 of them. You said both equal to 0. And you get 1 and -4. And nothing canceled again, so no holes. We'll get to that in a second. So I actually have 2 vertical asymptotes here, which is possible. You have one at 1. And you have one at -4. And you have a horizontal asymptote at 0. So we're going to have 3 graphs. We have one in here, so it's either top or bottom, one in here, top or bottom, and one in here, top or bottom. And we should only have one in each partition because otherwise it won't be a function. It has to pass the vertical line test. So there's only one graph in each side, either one on the right side, either top or bottom, one in the middle, top or bottom, one on the left, top or bottom. Again, I could plug in points. If I was doing a table, I have to plug in now 6 of them. A couple here, a couple here, a couple here. I'm just going to use a calculator. Use some technology. Again, easiest way to do if you press alpha y equals and use the updated functions. Make it just look like just the way you want it. So there you go. Hit graph. And then I can see, so it's going to be up here, it's a parabola down there, and it's up there. So it's kind of like this. Again, we're just doing a sketch. If I want more detail, I could either go to table on the graph, or I could make a table myself, so you can see the values. My domain, what can I not be? I can't be 1 or -4. My range, it looks like I can't be 1. I think it's a good one to check because sometimes this graph is a cubic graph in the middle. So it might be all row numbers, but in this case, it's y cannot equal 0. So there we go with that. Next one. Horizontal asymptote. Now here, it's a little tricky, right? On top, you only have 1 x. On the bottom, you actually have 2 x's. So the bottom is actually like an x squared if you multiply it all out. So the bottom's still bigger, so 0. Baroque asymptotes, split it, so the bottom equals 0. There we go. So you get -2 and 5. And nothing cancels out again, so no holes. Next one will have a hole, I promise. So let's graph this, -2, 5, asymptote at 0. Okay, so again, I could either make a table. I'm gonna use some technology. I'm gonna do technology again because I am lazy. So alpha y equals, got 2x over x plus 2, x minus 5. Hit graph. So again, down here. Now this is a cubic graph this time, and then up there. So again, like this, I'm just doing a sketch. Wanna hug it, and like this. I'm not a fan of that graph. It should be going more straight, but I'll leave it for now. My domain, domain never changes. It can't be these two. So x not equal -2 and 5. The range might change. In this case, it does. Look at the middle graph. It goes everywhere. You're like, how do you pass horizontal? Horizontal doesn't care about passing or not. You could pass horizontal. Most of the time you don't, but you could. Horizontal just tells you about the endpoint. What's going on as you get closer to infinity and negative infinity. It's all the horizontal tope tells you. So it's totally possible to cross the horizontal tope. In this case it does, so my range is all row numbers. Or negative infinity to positive infinity. Right, every value gets used. Next one. So this one, I can do the horizontal tope first. Top power is bigger than bottom power, so none. And to the rest, I got a factor. So let's factor the top. Two things to multiply get -8, add to get -2. So x minus 4, x plus 2, all over x minus 4. Now you see here, the x minus 4's cancel out. That gives us a hole at x equals -4. But I want to point out, our function's not done. Our function's not this, it's not this. Our function now is this guy. Right, that's our remaining graph. We have f of x equals this. This is our new graph. Do you have any Baroque asymptote? No, there's no denominator. The whole, right? I know it's at -4, but what's the y value? Just plug it in. -2. So that's where my whole really is. It's at -4 and -2. So I could go to -4, -2, and put a hole. Like right there. So I have a hole right there. And then how do I graph this thing? Well, what's the graph? It's this guy. We should all know how to graph y equals x plus 2, right? Y intercept at 2, slope of 1, so up 1 over 1. Be like this. Not my best graph, it should be more of a straight line, but there you go. So what's my domain? What's the one value you can't be? Well, right here, -4, right? It's the only thing you don't have. X on equal -4. Well, with the range, what's the one value you can't be? Well, this guy, the whole, -2. The hole in your graph. You can't be the hole in your graph. So that's my domain and range. Last question. What's the difference between the graphs of this and the graph of this? Well, what happens here? These cancel out and you get a hole at x equals -3. Other than that, these are the exact same graph. So that's the difference. One of these has a hole, one doesn't. This graph, if you graph this one to show you, you get a line at x equals -2. This graph, you get the same graph, but at x equals -3, you would have a hole in there. So the hole's the difference. The hole at x equals -3 is the difference. That's the video.